Something unexpected is surviving just half a light-year from the black hole at the center of our galaxy. Using the James Webb Space Telescope, astronomers have detected clear signatures of water and oxygen-rich dust around a dying star called IRS-3. And that is strange, because IRS-3 is sitting extremely close to Sagittarius A*, the supermassive black hole at the heart of the Milky Way. The region around Sagittarius A* is one of the harshest environments in our galaxy. So how can water survive there? And even more importantly, what does this tell us about where the raw materials for future stars and planets actually come from? To understand why this discovery matters, we need to look at the star itself. IRS-3 is not a young star being born. It is an old, highly evolved star approaching the final stages of its life. Stars like this can become enormous. Their outer layers expand, cool, and eventually begin flowing away into space in powerful stellar winds. That expelled material contains gas and dust. And that dust is important. Across the universe, dust grains become part of the clouds from which new stars and planetary systems can eventually form. But there was a problem with IRS-3. It is only about 0.55 light-years from Sagittarius A star. That sounds enormous. It is not. On the scale of the Milky Way, this is an extremely small distance from a black hole containing roughly 4 million times the mass of the Sun. The environment there is flooded with intense radiation and surrounded by turbulent gas. For years, astronomers have wanted to know whether a star could continue producing and releasing material under those conditions. Webb finally gave them a much clearer answer. It can. Using the telescope's mid-infrared instrument, or MIRI, researchers examined the infrared light surrounding IRS-3. Infrared is especially useful here because it can reveal relatively cool material hidden inside dusty environments. And when astronomers studied the spectrum, they found something particularly important. The dust around IRS-3 is oxygen-rich. Earlier observations had suggested a different chemical picture, one more consistent with carbon-rich material. But Webb's much more detailed infrared observations changed that interpretation. And then came the part that makes this discovery especially interesting. Water. For the first time, astronomers detected clear signatures of water in the material surrounding this evolved star so close to Sagittarius A star. That does not mean there is an ocean floating next to the black hole. It does not mean there is liquid water. And it certainly does not mean anyone has found evidence of life. The water is present as molecules within the star's surrounding material. But even in that form, the discovery matters. Because water is made from hydrogen and oxygen, two of the most important ingredients in chemistry throughout the universe. And finding it in this hostile environment tells us something about how surprisingly resilient stellar material can be. At first, the story seems straightforward. An old star is losing its outer layers. Those layers contain gas and dust. Webb detects water and oxygen-rich material. But there is another question. How is that material actually surviving? IRS-3 is losing matter while Sagittarius A* dominates the environment around it. The black hole itself is not simply vacuuming everything nearby into oblivion. A black hole's gravity becomes dangerous at close range, but being near one does not automatically mean that every surrounding object is destroyed. IRS-3 is still a star. Its own gravity holds it together. Its stellar wind pushes material outward. And the material that leaves the star can form a surrounding envelope of dust and gas. That envelope is where Webb's infrared observations become crucial. The researchers found layered dust extending enormous distances around the star, reaching roughly 10,000 times the Earth-Sun distance. Closer to the star, the dust is much hotter. Farther out, it cools dramatically. That creates a kind of chemical environment around IRS-3 where different molecules and dust grains can exist at different distances. And this is where the discovery becomes bigger than one unusual star. Because astronomers are trying to understand how galaxies recycle matter. Stars are not closed systems. They are cosmic factories. They build heavier elements inside their interiors, and near the end of their lives, they return some of that material to space. That material can eventually become part of something else. A new star. A planet. An asteroid. Or, under the right conditions, the chemistry from which more complex molecules can develop. So IRS-3 is effectively demonstrating that even near the violent center of a galaxy, an aging star can continue enriching its surroundings. But there is an important distinction here. The observations show that water and oxygen-rich dust are present. They do not prove exactly how every molecule formed. They also do not tell us that the material will eventually create planets. That part remains a possibility within the much larger cycle of cosmic matter. And there is still something we don't fully understand. Why does this material survive so close to Sagittarius A*? The black hole is not acting alone. The galactic center is filled with powerful stellar winds, energetic radiation, hot plasma, magnetic fields, and rapidly moving gas. Yet IRS-3 is continuing to shed material into that environment. The fact that Webb can identify the chemical fingerprints of that material means that at least some of it survives long enough to remain detectable. And that raises an even bigger question. If evolved stars can produce and preserve dust and water in such an extreme environment, how common is this process across the galaxy? The Milky Way's center contains many stars. Some are young. Some are old. Some are dying. And many exist in environments that would look completely hostile from the perspective of the relatively quiet solar system. If stars near the galactic center can recycle material this efficiently, they may play a much larger role in the chemical evolution of the region than astronomers previously realized. And Webb is only beginning to reveal what is hidden there. The telescope does not photograph water as a blue liquid. It detects the specific wavelengths of infrared light associated with molecules and dust. In other words, Webb is reading the chemical fingerprints left in light. That is what makes this discovery so powerful. We are not looking at water because we can simply see it. We know it is there because the light carries evidence of it. And that evidence has now come from a place where many of these molecules were not expected to survive so easily. Half a light year from a 4 million solar mass black hole. Around a dying star. Inside one of the most violent neighborhoods of the Milky Way. Water is still there. And perhaps the most fascinating part is what this discovery does not tell us. It does not reveal a hidden ocean. It does not reveal extraterrestrial life. It does not change the physics of black holes. Instead, it reveals something more subtle, and arguably more important. The universe is better at preserving and recycling the ingredients of matter than we sometimes assume. Even in places dominated by extreme gravity and radiation, stars can still manufacture, release, and redistribute material. IRS-3 is dying. But the material it leaves behind does not necessarily represent an ending. Some of it may eventually become part of something new. And somewhere, perhaps millions or billions of years from now, material produced by a dying star near the black hole at the center of the Milky Way could become part of another cosmic story. The strange thing is not that water exists in the universe. We already knew that. The strange thing is where Webb has now found it. So the next time we look toward the darkest region at the center of our galaxy, we may have to imagine something unexpected surrounding that darkness. Not emptiness, but dust, gas, molecules, and the raw ingredients of worlds yet to exist.